All right, everyone. Today, let's understand ANOVA, analysis of variance. Imagine you are comparing exam scores from 3 different classes. A t-test works for 2 groups, but what about 3 or more? That's where ANOVA comes in. It helps us determine if the differences in the group means are statistically significant or just random chance. ANOVA is a super handy tool when you want to compare multiple groups without running several t-tests, which increases error rates. Don't worry about the math for now. We'll focus on the concept and when to use it. So let's get ready to explore how ANOVA makes sense of data differences. What is One-Way ANOVA? One-Way ANOVA stands for Analysis of Variance and compares the means of 2 or more independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. This test is also known as one-factor ANOVA, one-way analysis of variance between subjects ANOVA. The variables used in this test are known as dependent variable, independent variable, also known as the grouping variable or factor. This should be categorical, that is nominal or ordinal, and include at least 2 groups. Is independent sample t-test and one-way ANOVA the same? Both the one-way ANOVA and independent sample t-test can compare the means for 2 groups. However, only the one-way ANOVA can compare the means across 3 or more groups. If the grouping variable has only 2 groups, then the results of one-way ANOVA and the independent sample t-test will be equivalent. In fact, if you run both an independent sample t-test and a one-way ANOVA in this situation, you should be able to confirm that t square is equal to f. Assumptions of ANOVA. First, the dependent variable must be a continuous variable. Second, the independent variable must be categorical in nature with 2 or more groups. Third, cases that have values on both the dependent and independent variable. Fourth, there should be independence of observations. That is, subjects in the first group cannot also be in the second group. No subject in either group can influence subjects in the other group. No group can influence the other group. Fifth, you should take a random sample of data from the population. Sixth, the dependent variable should be normally distributed well approximately for each group. 7. Homogeneity of variances must be met. That is, variances should be approximately equal across groups. And 8th, there should be no outliers. The hypothesis of one-way ANOVA. The null and alternative hypothesis of one-way ANOVA can be expressed as H0, where mu1 is equal to mu2 is equal to mu3, and so on, where UK, all K population means are equal. H1, at least one mu I is different. That is, at least one of the K population means is not equal to the others, where mu I is the population mean of the ith group starting from I equal to 1 to K and so on. The test statistic for a one-way ANOVA is denoted as F. For an independent variable with K groups, the F statistic evaluates whether the group means are significantly different. So far, so good. Let's pause and reflect. See if you can answer this. What is the primary purpose of ANOVA, that is analysis of variance? And your options are A, to compare the variances of 2 independent groups, B, to test for significance difference between the means of 3 or more groups, C, to determine the relationship between 2 continuous variables, And D, to analyze the impact of a single variable on one group. You can pause the video, introspect, and then answer. Yes, the correct answer is B, to test for significant differences between the mean of 3 or more groups. Let's now see how we can run one-way ANOVA in SPSS. We will go back to the scenario we had discussed in the independent sample t-test video. Let's recap the scenario. The ABC company has switched to an online recruitment process after the COVID-19 pandemic. It wants to assess the experience of the candidates with respect to the newly implemented recruitment process. The company has advertised for vacancies at different levels, namely entry-level positions, management trainee, deputy manager, manager, and senior manager. The company devised a suitable metric for capturing the candidate experience and kept track of the demographic data of the candidates, such as gender and the level which they had applied for. The company wants to find out if the candidate experience with respect to the new online recruitment process differed across different levels. So here, there are 5 levels across which candidates had applied. The candidate experience is a dependent variable here. Let us now switch to SPSS for a hands-on demo. So let me show you the data file in SPSS. First, let us look at the variable view. We've got 4 variables here: candidate ID, candidate experience, gender, and level applied for. The candidate experience has been measured on the scale level, whereas if we talk about gender, it has been measured at the nominal level. Gender has got 2 categories, 1 for male and 2 for female. Likewise, if we look at the level applied has got 5 levels. Let's look at what these levels stand for. 1 is entry level, 2 management trainee, 3 deputy manager, 4 manager, and 5 is senior manager. So this is how the variables have been designated. Now let's look at what our data looks like. So if we look here, this is the data view. Now we can toggle between the coding that we have given to the labels by simply clicking here. So here if you click, it will give you the coding, whereas if you toggle again, it's going to give you the labels here. Now we want to find out whether the experience that the candidates had when they applied for different levels, was it the same or were there significant difference in the experience that they had. So to do this, we will run the one-way ANOVA. We'll go to analyze, then we go to compare means, and then in compare means, we'll go to one-way ANOVA. Candidate experience is our dependent variable, and we'll shift this to this box here, candidate experience. Level applied is the factor, so we will transfer it to this box here, factor, right? We can go to options, and here for the time being, we can select means plots. We click continue. Now let us click OK. The output is obtained in the form of this table here, the ANOVA table. If you look at the significance value, the p-value here, it comes out to be 0.00. Now this p-value is less than 0.05, and hence we conclude that we will have to reject the null hypothesis. The way to interpret is that the experience that candidates had when they had applied for different levels or different positions was not the same. It was significantly different across the different levels at which they had applied. We also have the means chart here, which you can have a look to see how the candidate experience varied across the different positions they had applied for. So ANOVA gives the overall picture. In this video, we explored how ANOVA helps compare means across multiple groups, its assumptions and hypotheses. We also demonstrated how to perform a one-way ANOVA in SPSS using a practical example. The results showed significant differences in group means, highlighting ANOVA's value in analyzing data effectively. Thank you for your attention. In the next video, we will take the discussion on ANOVA forward.